you everyone for taking your time to join. This is NAVAL-SEM. It's an offline desktop application for structural equation modeling (SEM) that I've been building primarily to reduce software access friction for research students, especially in contexts where the commercial structural equation modeling tools are expensive or difficult to access. The idea started very simply. Um, there is a real accessibility problem. I wanted to see whether a modern offline structural equation modeling workflow could be made available as an open and transparent desktop application. The software currently supports CB-SEM workflows and includes a visual drag and drop model builder. Users can also work directly with lavaan style syntax if they prefer a more code oriented workflow. Let me quickly show you the workflow. Firstly, I load a dataset, and this dataset is loaded from here. This is a dataset with all the files. If you want to verify the files, you can open this dataset in Excel as well. It has 300 rows, 301 rows divided into L1, L2, L3, S1, S2, S3, T1, T2, T3, 9 columns. Let me close the file here. So these are all loaded here. Once the data is loaded, the application previews the column and basic structure. Now I can define latent constructs visually. I'll create a latent variable called trust. So I've already typed trust here. I can put trust somewhere here. I can add a latent variable called satisfaction, and I can drag it and I can drop it here. And I can create define a latent construct. I can create a latent variable called loyalty. I'm defining a latent variable called loyalty and dropping it here. And then I can I can click on observed indicator, and I can attach T1 as an observed indicator to trust, T2 to trust, T3 near trust, S1 to satisfaction, S2 satisfaction, S3 satisfaction, L1 to loyalty, L2 loyalty, L3 to loyalty. Next, I draw the structural relationship between constructs. For that, I use the function called drawPath. I click on trust, I click on the target, I click on trust, I click on the target, I click on trust, I click on the target, I click on satisfaction, I click on the target, I click on satisfaction, I click on the target, I click on satisfaction, I click on the target, I click on loyalty, I click on the target, I click on loyalty, I click on the target, I click on loyalty, I click on the target. So now I have drawn a structural relationship between constructs. Once the model is built visually, the software automatically generates the corresponding SEM syntax. SEM syntax is structural equation modeling syntax internally. How do you see that syntax? Click on syntax, it shows you the syntax. Or you can come to model builder. This is important because it allows user to transition gradually towards reproducible syntax-based workflow rather than remaining fully dependent on drag and drop interfaces. Now I click Run Analysis. The engine estimates the model and returns parameter estimates, path coefficients, standard errors, p-values, fit indices like CFI, RMSEA, SRMR, AIC, BIC, and bootstrap outputs where applicable. There is also HTMT based discriminant validity assessment support. One feature I personally consider important is export capability. The model can be exported as runnable R, lavaan code, or Python SEMOP code. That helps students move towards more reproducible and transparent research workflows instead of getting logged into a single proprietary interface. Another design choice is that the application works fully offline after installation. There is no license ever server dependency, no login requirement, and no internet connectivity needed during analysis. The project is still evolving, and there are many advanced SEM and PLS-SEM capabilities. Planned for future versions. But the primary objective right now is to make SEM tooling more accessible, transparent, and easier to onboard for research students. I am very interested in feedback from faculty, PhD scholars, and methodology instructors because that feedback will shape the next iterations of the platform.